In the previous video, we talked about addition of hydrogen halide to alkene. And we worked out an example where we had a symmetrical alkene, as in they were same number of hydrogens on either of the carbons that had double bonds. But what if it was a unsymmetrical alkene? What if it was a situation like this? This is an unsymmetrical alkene. And why is this unsymmetrical alkene? Because when you break through this double bond, you get a carbon that has a hydrogen and methyl, and a carbon that has a methyl and methyl. So this is an unsymmetrical alkene. So in this case, where would the halogen attach and where would the hydrogen attach? In other words, what product are you expecting? Do you expect this? Or are you expecting a hydrogen here and a halogen here? So where will the hydrogen and halogen attach? So is there a criteria? Yes, there is a criteria. We look for the formation. In such a case, the first step, the carbocation formation, is very critical. What happens in this case is that we get a hydrogen, a carbocation. So our alkene is like this. Right? So when we are adding, say, HCl to this, the first step is the electrons from here will react with H plus from HCl, right? So in this case, what kind of a carbocation will form? Will it be this one? Or will it be this one? The rule is that the carbocation where the carbon plus the positive charge should be in such a way on the carbon which has maximum number of alkyl groups. Now think about it. This plus charge has a hydrogen and an alkyl group, whereas this plus charge, this carbon which has the plus charge, has an alkyl and an alkyl group. So this carbocation has more number of alkyl groups. This has one alkyl group, this has two alkyl groups. So this is the more stable carbocation. So again, the rule is the more stable form of the carbocation is the one where the C plus is attached to the most alkyl groups. So in this case, what happens is that we have a situation where we have H, CH3, CH3, CH3 plus and H. And then the Br minus or the Cl minus, Br minus or the Cl minus reacts with this one, and we end up with an alkane or alkyl halide that looks like this. Okay, so this rule, the rule where we are talking about the rule for the formation of carbocation, is known as Markovnikov's rule. This is known as Markovnikov's rule. I have to write it some other place. Markovnikov's rule. Markovnikov. This is known as Markovnikov's rule.